Hello friends, welcome to Ionic character of a covalent bond. So the learning objectives of this video are understanding ionic character of a covalent bond and its types on the basis of the electronegativity difference to understand our ionic character more clearly in case of the covalent bonds. We will also discuss the ionic character in our homonuclear diatomic molecules and also in our heteronuclear diatomic molecules. Friends, we will discuss here that how the electronegativity difference affect the ionic character and how the polarity in a molecule affects the covalent bond. We will also discuss the range of the electronegativity difference for the ionic characters. So let's start. So what is ionic character? The polarity in a covalent bond is due to the electronegativity difference between two bonded atoms. It's called ionic character. Greater the electronegativity difference between bonded atoms, greater is the ionic character. Do you know that no bond is completely covalent or ionic? Every bond having a certain amount of ionic or a covalent character. Friends, all the ionic bonds having some degree of the covalent character and the covalent bonds having some degree of the ionic character. Now we will discuss the ionic character in a covalent bonds. Friends, do you know that what are covalent bonds? Yes, the covalent bonds are formed by the sharing of electron pair between the two atoms. So friends, on the basis of electronegativity difference, there are two types of the covalent bond. One is non-polar covalent bond and the other one is polar covalent bond. In the non-polar covalent bond, there is an equal sharing of electron pair between the two atoms. Whereas in case of the polar covalent bond, there is an unequal sharing of electron pair. Look at here, in case of a non-polar covalent bond, here is an example of a hydrogen molecule. Here the two electrons are equally shared between the two hydrogen atoms. Whereas in case of the polar covalent bond, here is an example of hydrogen fluoride. We know that the fluorine is the most electronegative atom of the periodic table. Therefore, it having a partial negative charge. Whereas the hydrogen is an electropositive atom. Therefore, it's having a partial positive charge. Due to this electronegativity difference, the electron pair will be shifted more towards the fluorine and as a result there is an unequal sharing of electron. Friends, let's discuss that how there is an ionic character in case of the covalent bond. Friends, we know that in the non-polar molecules or in non-polar covalent bonds, there is an equal sharing of electron pair between the two atoms. So, how the electronegativity difference will be there in case of the non-polar molecules? So, friends, let's discuss the forces in the non-polar molecules. These forces are called London dispersion forces or also known as dipole-induced dipole forces. So by definition, the London dispersion forces are the weakest forces between the opposite ends of the temporary dipoles. Friends, remember that these London dispersion forces are present in both polar and the non-polar molecules, but these forces are more significant in the non-polar molecules. Because in case of the non-polar molecules, there is no other force present in the non-polar molecules. Friends, let's discuss the formation of the London dispersion forces in case of the non-polar molecules. Remember that in case of the London dispersion forces, the temporary dipole formation takes place. So how these temporary dipoles form? Look at here, we have an atom. Here in an atom, there is a symmetrical electron cloud distribution. We know that the electrons are continuously revolving around the nucleus of an atom. So a times come when all the electrons shifted towards the one side of an atom, whereas the nucleus shifted towards another side. So at that time there is an unsymmetrical electron cloud distribution. And as a result, two poles are created here. As you can see here in our diagram, there is a partial positive pole and a partial negative pole. And as a result, the temporary dipole formation takes place. So friends, as you can see here in a diagram, that when a temporary dipole comes close to a symmetrical atom, its electron cloud repel the electron cloud of a symmetrical atom, and as a result, a dipole is induced in it. This dipole is called induced dipole. Friends, remember that this dipole formation is for a very short period of time. Therefore, the electronegativity difference is less than 0.9%. In this case of the non-polar molecule, we ignore the percent ionic character because this dipole formation is very short period of a time and there is an electronegativity difference of a point or less than 0.9%. Therefore, we ignore here the percent ionic character. But actually the ionic character are also present here in case of the non-polar molecules. So the second type of a covalent bond is a polar covalent bond. Friends, remember that the polar covalent bond are formed by the unequal sharing of electron pair between the two atoms. And this unequal sharing of electron pair is because of the electronegativity difference between the two atoms. Friends, we know that the more electronegative atom having a more tendency to attract an electron pair towards itself as compared to the less electronegative atom. So as a result of this electronegativity difference, the partial charge formation takes place. Friends, as you can see in a diagram, we have two atoms. And one having a partial negative charge means that it having a more power to attract an electron pair towards itself, and the other having a partial positive charge, it means that it having a less tendency to attract an electron pair. And as a result of this electronegativity difference, there must be an unequal charge, there must be an unequal sharing of electron pair. So friends, remember that when there is an electronegativity difference between two atoms, there must be percent ionic character. So in case of the polar covalent bond, we can't ignore the ionic character in this case. Friends, we will also discuss the ionic character range of the polar and the polar covalent bond and the non-polar covalent bond in this video. So please watch this video till end. Ionic character in a homonuclear diatomic molecule. So friends, before discussing the ionic character, we must know that what are the homonuclear diatomic molecules. So homo means similar or identical, nuclear means nucleus, di means two, atomic molecule means that the molecule formed by two atoms. So friends, simply look at here that the hydrogen molecule, chlorine molecule and the oxygen molecule are formed by the combination of two identical atoms. Therefore, they are called the homonuclear diatomic molecules. So what about the electronegativity difference in this case of the homonuclear diatomic molecules? So friends, to understand the electronegativity difference in this molecule, let's take an example. Imagine that the two friends are playing the tug of war and both of them having the same energy. Then who will win? Friends, we know that if two friends having the same energy, that no one will win. The match will be tied between these two friends. Similar is the case of the diatomic molecules. So friends, look at here that the two hydrogen here having no electronegativity difference. Therefore, in this case, the molecule having no ionic character. And in this case, the molecule are non-polar molecules. Similarly, in case of the chlorine, there is having no electronegativity difference between these two chlorine atoms because both having the same power or energy. So in this case, again, there is zero ionic character and the molecule is a non-polar molecule. Now look at here, oxygen molecule. Both the oxygen having no electronegativity difference, therefore it's having 0% or no ionic character. So from this we come to know that in case of the homonuclear diatomic molecules, there is no electronegativity difference between the atoms, therefore they having no ionic character, and these molecules are therefore called the non-polar molecules. Ionic character in a heteronuclear diatomic molecule. So what is the heteronuclear diatomic molecule? Hetero means dissimilar, nuclear means nucleus, di means two, atomic molecule means atoms molecule. So simply we can say that the heteronuclear diatomic molecules are the molecules formed by the combination of two dissimilar atoms. Look at here that the hydrogen fluoride, hydrogen chloride and the hydrogen iodide, these molecules are formed by the combination of two dissimilar atoms. Therefore, they are called the heteronuclear diatomic molecules. So what about the ionic character and the electronegativity difference in this case of the heteronuclear diatomic molecules? So to understand the electronegativity difference in these molecules, let's imagine that the two friends are playing tug of war. And in this time, both friends having an having an energy difference. So what will be happen? A friend having a greater energy will pull the rope towards itself. So as a result, he will win. Similarly, in case of the hydrogen fluoride, the fluorine having a greater pulling of an electron towards itself, whereas the hydrogen having a less pulling power. So as a result, the partial poles will formed. Look at here that the fluorine having a partial negative charge due to the greater pulling power and the hydrogen having a partial positive charge because it is an electropositive atom. So in case of the dissimilar atoms, the electronegativity difference is created between the two atoms, therefore it must have an ionic character. Look at here, in case of the hydrogen fluoride, there is an electronegativity difference. Therefore, in this case, the ionic character is 43%. Now look at here, in case of the hydrogen chloride. What will be happen here? Here, chlorine is more electronegative. It means that its pulling power of electron towards itself is more as compared to the hydrogen. As a result, an unequal sharing of an electron pair will form, which result in the formation of the charge. Look at here that the chlorine having a partial negative charge due to the greater electronegativity and the hydrogen having a partial positive charge due to its electropositive atom. As a result of this electronegativity difference or the polarity, there is an ionic character that is the 17%. Now what about the hydrogen iodide? Here iodine is more electronegative, therefore it having a partial negative charge, whereas the hydrogen having a partial positive charge. So as a result of this unequal sharing of an electron between the hydrogen and iodide, it's form a partial charge formation. And we know when there is an electronegativity difference between two atoms, so it results in ionic character. So in case of the hydrogen iodide, the ionic character is 5%. So friends, now we come to know that if there is an electronegativity difference between the two atoms, as in case of the heteronuclear diatomic molecule, so in this case there must be an ionic character and the molecule as a polar molecule. Let's discuss the increasing order of the ionic character. As we know that the covalent bonds having some degree or range of the ionic character. The nonpolar covalent bonds having a London dispersion forces, and due to these London dispersion forces, temporary dipole formation takes place. We know that these dipoles are for a very short period of the time, and here the electronegativity difference is less than 0.9%. Therefore, we ignore this electronegativity difference because it's very less, and we say that these bonds are 100% covalent bond. Whereas in case of the polar covalent bonds, we can't ignore the electronegativity difference here. Here we see that partial charge formation takes place, and as a result of these partial charges, there is an electronegativity difference which results in a pole formation. So here in case of the polar covalent bond, there must be an ionic character. And we know that in ionic bond, there is a complete transfer of electron from one atom to another atom. So let's discuss the effect of the electronegativity on the ionic character. We know that in case of the covalent bond, or in other words, we can say that in case of the non-polar covalent bond, there is an equal sharing of an electron pair. Therefore, no electronegativity difference is there in case of the covalent bond. Or in other words, we know that there is a London dispersion forces present in the non-polar covalent bond. And these forces play a role for a very short period of the time, and the poles are created for a second of the time. Therefore, we ignore this electronegativity difference or these temporary poles. And as a result, we can say that there is no electronegativity difference in case of the non-polar covalent bond. But as we go down towards a polar covalent bond, we can't ignore the electronegativity difference. Look at here, in case of the hydrogen fluoride, we know that the fluorine is the most electronegative atom of the periodic table. Therefore, it's having a partial negative charge and the hydrogen having a partial positive charge due to a very less electronegativity, or we can see that it's an electropositive atom. So as a result of this electronegativity difference, partial poles are produced here, and there is an ionic character present in case of the hydrogen fluoride. But as we go down towards the ionic bond, here in case of the ionic bond, there is a complete transfer of electron from one atom to another atom, as in the case of the sodium chloride. So, when we go from non-polar towards the polar covalent bond, there is an increase of the ionic character. Now, let's discuss the electronegativity range for the ionic character. So, if the electronegativity difference between the atoms in the molecule is from 0 to less than 0.9, so we can ignore this electronegativity difference, and in this case we can say that there is no polarity and there is an equal sharing of an electron. As a result, this molecule is called non-polar molecule, and the bond here is called non-polar covalent bond. So in this case, we can say that there is no ionic character. Whereas if the electronegativity difference between the two atoms in a molecule is from 0.9 to 1.7, then we can say that there is an electronegativity difference and there is a less polarity. So in this case, there is an unequal sharing of an electron, and this molecule is now called a polar molecule and having a polar covalent bond. And in this case, the ionic character is a 50% ionic character. Whereas if the electronegativity difference between the atoms in a molecule is greater than 1.7, then in this case, this molecule having a more polarity, and in this case there is a more pulling of an electron pair towards the other side, and this molecule is called a polar covalent molecule and having a more ionic character as compared to the less electronegativity. So friends, the key points are that the ionic character is due to the electronegativity difference between the two atoms in a molecule. Greater the electronegativity difference between the atoms, greater will be the ionic character. So friends, we also know that if the electronegativity difference between the atoms in a molecule is less than 0.9, so we ignore this electronegativity difference and we say that this molecule is a non-polar molecule. Whereas if the electronegativity difference between an atoms is greater than between the 0.9 to 1.7, so we say that this molecule is a polar molecule and having a 50% ionic character. And if the electronegativity difference is greater than 1.7, so in this case we can't ignore the electronegativity difference and we say that this having a greater polarity and now the ionic character is greater than 50%. So the molecule having a greater ionic character. Friends, if you like my video, then don't forget to like, share and subscribe my channel Digital Chemistry.